ladle tilted, and from there it goes down to the water-cooled copper mold, and steel strand emerges from this mold, which is not completely solidified, but once it reaches this area, this place, it's almost completely solidified. So here it is cut into pieces, and the process continues. It goes around the clock, and that's why it's called continuous casting. No stationary molds are required. So that's why it's called continuous casting process. And the ladle is one of the main tool used in this continuous casting process. Ladle is used as a transportation tool. Using the ladle, we transport the molten steel from the AOD converter, argon oxygen decarbonization furnace, AOD, to the casting machine. So the ladle has basically the ladle needs to be strong enough to sustain high temperatures, and it needs to be insulated so that there's lesser temperature losses during the transportation. So for this purpose, it's made of several different layers. The first inner layer, the innermost layer is made from refractory bricks. Refractory bricks are made from materials that are resistant to heat. And then there's a mass layer, and then there are some insulation layers which insulate the molten steel from the ambience. And then the outer side of the ladle is a steel shell that encloses all those inner layers of the ladle. And the top of the ladle is covered with a lid. And these points show the points where the nodes where you will put with Per and John put the thermocouples for measurements of temperature. This is the ladle cycle, how the ladle operates. From the continuous casting, it goes to the maintenance station where necessary maintenance is carried out. If relining is needed, relining is done, and if the nozzles or the sliding gates needs to be replaced, then they are replaced at this ladle maintenance station. At Autocomp or Vesta Works, we usually carry out a major maintenance after 35 charges. 35 times the ladle is filled, and the inner lining of the ladle is changed after every 70 charges. And then there's the preheating station where a ladle is brought for preheating. The ladle needs to be at a suitable temperature for the steel to be poured into it. So if the temperature is below a certain limit, then we need to give it some heat. But if it is, if it's already at a good temperature, then we may skip the ladle preheating station and go directly to the converter tapping. At the converter tapping, at the AOD furnace, we set the initial carbon and alloy content of the molten steel, and then we tap that steel into the ladle, fill it, and then we cover the molten steel with a slag layer so that insulation is achieved from the top, and then we cover the ladle with a lid, and then it's ready for transportation. It's this phase where most of the heat is lost because depending on the schedule of the ladle at the facility, maybe the ladle will have to wait for a long time, so heat will be lost here mostly. So to adjust this heat loss and to fine-tune the content of carbon and different alloys in the molten steel, we need a secondary refining stage. So at the ladle furnace station, we carry out the secondary refining. We add some alloys, we fine-tune the composition of the steel, and if the temperature of the molten steel is higher than normal, then we add some scrap metal, and if it is lower, then we give heat burst to this molten steel in order to bring it to a suitable temperature, and then it goes for casting. And then again the cycle continues like this. There is temperature modeling, effects of temperature on the process. The effects of temperature has a lot of effects on the modeling, on the process. The temperature needs to be at a specific level. There are several grades available for steel. There are several steel grades available. So for each steel grade, there is a different temperature that we need at casting, at the instant of casting. So we need to have a specific temperature at the casting instant, and also if the temperature is very low, then maybe the nozzles of the ladle can get clogged, which is undesirable, and if the temperature is too high, then a breakout can occur, which can lead to disastrous conditions. So that's also undesirable. So that's why we need a model for a ladle, for the ladle, so that we can model the temperature of the ladle to be at the accurate temperature required for the modeling, for the casting. Then basically there are three modeling methods available. We have black box modeling, white box modeling, and gray box modeling. In fact, black box modeling, we know the inputs and outputs of the system, and we identify the system using those inputs and outputs. And in white box modeling, we model the system using mathematical equations, and the system is known. And in gray box modeling, we combine the properties of both these modeling techniques. So this usually results in a better model for the system. The system inputs and outputs, in this case, the system inputs were the steel weight and initial steel temperature, and the outputs were the current steel temperature at any instant and the ladle water temperatures at any instant. So the model was basically an ODE model, ordinary differential equation model, which was calibrated using the data from the process, and this model has basically two parts. One is for the case when the ladle is empty, and one is for the case when the ladle is filled. So this is the basic description of the model. Now let's come to the common features of the GUI. The GUI has some common features that will be active no matter which tab is active at that moment. First, the logo just represents the company for which the GUI was made, and then there's a tab panel. There are 7 different tabs. You can switch between different tabs, and whichever tab is active, it will show up here. And then there are some checkboxes for X and Y, grid lines to switch on and off. And then there are buttons, start, stop, save, close, and they are for usual start, stop, save, and close, as we use them usually in your usual life. But these two special buttons, I will describe them in the next slides. And this is some axis, defining an axis for a plot. I will also explain this in the later slides. Then there is a space for messages. If during the process there is a warning or error message that appears, then the latest error message or warning message will appear here. And this GUI works online with the simulation, works online, and it updates every minute. So this is basically a save functionality. When I press this save button, a window will open. It will ask me to the place and the name for the file to save. And when I give it a place, give it a location and the name of the file, then it will say these different parameters. And when I press the start button, it will turn inactive because we cannot restart the system again and again because it's a crucial simulation, and it needs to run for 250 hours continuously. So that's why once started, we need not to restart it again. So that's why I have disabled